All right. So in the last lesson, we talked about control flow, and that control flow is made up of primarily two different types of procedures: conditional statements, and then iteration or looping type of structures. So we're going to go ahead and talk about the looping portion in this lesson. And bottom line is often we need to execute repetitive code statements for a certain number of times. Sometimes that number of times is undetermined, and then sometimes that number of times is predetermined, right? But regardless, we need to operate or perform certain operational statements or code that execute certain operations multiple times, and we can do that with different types of looping constructs. The primary looping constructs that you will see within R are for loops, while loops, and repeat loops. For loops are common across all programming languages pretty much. And so you'll notice that R for loops behave very similar to other languages. Just the way that we incorporate them into certain bracket notation may look a little bit different, but at the end of the day, it's a normal procedure. So a good rule of thumb that you will see is if you are executing certain code more than 2 times, so say 3 times, 4 times, 5 times or more, that's usually when you want to start thinking about, do I need to implement a for loop? Now, while and repeat loops are very similar, the primary difference is that while and repeat, we want to execute code until a certain condition holds. Okay? In for loops, we basically have a predetermined number of times that we want to perform some iteration. And so that's the main difference between for loops and while and repeat. These last two are execute code until a condition is met. For loops is execute code a certain number of times. Now there's going to be 2 additional code constructs that we're going to look at, and these are called next and break, and they're often used in conjunction with looping constructs. All right, so one thing to point out, R it's a vectorized and functional programming language, which there are certain tools within R that can help us minimize the use of these kind of looping constructs. Now, if you dig into the lesson reading, there's going to be a whole section that has to do with how can we do looping procedures, but within a functional programming context. And it's very informative. It's great content. You definitely want to go ahead and take time to go through that. However, we're not going to cover that material in this presentation. What the objective of this presentation is make sure you have a good foundation of the idea of loops, for loops, while loops, and repeat loops. And once you have that foundation, building on that with the functional programming syntax that you'll see in the reading will not be that big of a jump. All right, so let's talk about for loops. A very basic for loop. It's going to have pseudocode like this, where for I within a certain sequence of values or elements, we want to perform some code. Okay, so in this case, we would just say for when I is basically the values of 1 to 100, right? So this is gonna, for I in the sequence of 1 through 100, perform these tasks. Okay, so take a look at this loop here and answer, what is this loop? What do you think the output is going to be, right? What's the objective? Really what it's doing is we're going to take I in the values of 2010, 2017. So what does that mean exactly? Well, if we look at 2010 to 2017, right, we're saying we have this vector of values 2010 through 2017. So for each year, right, I is going to equal that year. So for iteration 1, I is going to equal the first value in that element, 2010. And so then we're going to go ahead and print, and that's why it says paste this year is, and then I, right? So the value of I has taken on 2010 in this case. Then it's going to do the next iteration. So then it's going to go to the next element, and that's going to be 2011. So when I is 2011, we're going to execute this code, which we see here. The year is 2011, and so on. So in each iteration, I takes on the value of whatever element is in this sequence for that iteration. All right, so often the length of the sequence is pretty much determined by some predefined variable. So often we have a variable in our code, and based off of the number of observations or number of elements in that object, we want to execute some code. And you're going to see basically two very common approaches to doing this. Option one is where we say for I in 1 through the length of x. Right, so what is 1 through the length of x doing? Well, that is basically saying, let's make x be this vector. So now x is 2010 through 2017. So 1 through the length of that, it is just creating a new vector where it's the index values for each of these elements. Element 1, 2, 3, 4, all the way through 8. Right, so you'll see code a lot of times it looks like this. Let's iterate through each index of the object. I is going to take that index value on. So I is going to take on the values 1, 2, 3, and so on. And then we do some stuff here. And what we'll do is often index the object for that ith index element. Okay, so that is one very common approach you'll see. The second approach you'll see, and is probably becoming more popular, is this, where we use this seek along x. What is seek along x doing? Well, it's doing the same thing, and it's creating the index values along the object of x, right? So now we get the exact same index values of 1 through 8, and you'll see the same procedure here, okay? So take a look at these, and can you answer, do you prefer one over the other? Well, for the most part, they're going to operate in a very similar manner. The primary difference is if we happen to have an object that is empty, right? So here, x is just an empty vector. There are no values, right? So if we do length of x, the length is actually 0. The problem that happens is when you use this 1 through the length of x, this approach, now it actually counts down from 1 to 0. And so what will happen is the for loop will still iterate. Even though this object is empty, it's going to iterate from the value 1 down to 0. However, most of the time, if an object is empty, we don't want that for loop to run, right? And that's the benefit of using this syntax. For I and seek along x. Well, when you seek along x and x is empty, then what happens is you get this integer 0, and so this is not going to actually execute, right? So that is just a key thing to remember. We prefer to use this syntax where we seek along x versus just doing 1 through the length of x. Okay, so there's quite a bit of code on this slide. Don't get too hung up in that. But what we are demonstrating here is that there is a definite performance difference of our for loops when we do what's called growing the output object or filling the output. Okay, what does that mean? Well, often you're going to see in for loops where we want to execute over some object, right? And so here we have this means object, means, okay? And so what we want to do is we're actually going to, let's see, this is creating 100 different vectors with 10,000 observations. So what we actually do is we are creating we're generating data based off of the mean value within this means vector here. And what it's doing is it's going to just create this data set. Now, so this is a very simple function. It's not really doing anything that's too complex. But there's two ways that we could grow this output or create this output. The first option is what we call growing the output. And what this means is we create this empty, in this case, empty list, right? So if we look at this out list, out is empty. But what we're going to do is we're going to iterate over this vector and we're going to create a bunch of generated data. And then we're going to go ahead and fill in this list, okay? And what happens here is we create an empty list, and then each time we add on to it, we concatenate to that list. So we append to it, we grow it, we make it larger over time, okay? And we see this doesn't take a whole lot of time, right? So we got, a little bit over 1 second. Now the other option is we create an output that is the same length as the expected output, right? So the first here we saw that the first approach created an empty list, and then we fill that list, we add on to that list. The second approach here is we create a list, right, that has the length of the list elements that we want to create in our for loop, and we're going to fill these in later. We've created the size of that output. It's just the size is there, but the elements need to get filled in. Now, when we do that, the exact same procedure here, what happens is our total time is 0.07 seconds, right? So we've gone from a little bit over 1 second down to 0.072 seconds. Now neither one of these seems like a large amount of time. But what happens is when you start operating and doing complex operations over a very large data set, or you have a very large number of iterations you want to perform, right? This can just blow up, right? And the difference becomes much more exaggerated. So the key takeaway here is when looping over very large data for the purpose of saving some output, what you want to do is you want to instantiate the final object size before executing the loop. So we want to fill. We want to create the final output in its total size, like a shell of it that we want, and we're going to fill it in versus create an empty object and we add on new elements with each iteration. All right, so what I want you to do here is we can see all the data sets that we have in the data folder for this lesson, right? So we have a bunch of month data, month CSV files. And so say we want to import one of these files, right? Say we want to import month 1 CSV, right? We would execute this string of code here. And what this does is, let's go ahead and follow this here. Library here. All right, so our first df is just this value of the first CSV file. Now, what we do here is we execute this code, and what this code does is this imports our CSV file, and then what it does, so it imports the CSV file, then this is going to create a new name for that, because what we've done is we've just imported the CSV file as df, right? So we have our data here, but df is too general of a name for our data frame. So what we do is we're going to create a name based off of the file name. So the new name of this data frame is going to be month01, and then we can assign that data frame with this new month name, right? So now when we do that, we have month 01. We now have that data frame in here. All right, so that's great. But what I want you to actually do is turn this code into a for loop where you're going to iterate over each element in this vector, right? Each CSV file for all the different months, and you're going to import them, and then you're going to go ahead and create a new name for that file, and then you're going to dynamically rename that file. Okay, so take a few minutes and see if you can work through this. All right, so what this looks like is, well, one, we're going to look over for I in each file, right? So basically for each file in this list or in this vector, for each one of these files, right, I becomes that value. And so then what we do is, the first step is we read in that file. So here we're using I because I takes on the value of that CSV file name. So we read in that file name. We then get the new name based off of the value of I, but we remove the CSV extension. And we assign the data frame of that new name. And then at that same time, we still have that DF object, that DF data frame out there, and we can just use RM to remove it. Right, so when we execute this code, right, so I can go ahead and just execute this. It iterates over each one. Now, if we look within our environment, we see we have month 1, month 2, month 3, month 4, all the way to month 11. And each one of these is a different data frame containing the data in that CSV file. All right, so let's talk about how we can control the sequencing of our, or the execution through our for loop. So there are two ways that we primarily control the progression of a loop. One of them is with the next statement. And so what next does, it terminates the current iteration and advances to the next. Okay, so we're not jumping out of the for loop, but what we're doing is we're just going to go ahead and skip that execution or the rest of the code in that iteration and go to the next value of I, or the next element within the object we're iterating over. Okay, so for example, here we have this vector where X is just simply a vector of 1, 2, and then a missing value, and then 3. Right, so what we do here is for I in X, right, what we're going to do, we're going to have an iteration of code where this iteration of code primarily here, it just is going to print out the value of I. However, up here, before we get to this code execution, we have this conditional statement, if. So check if I is actually a missing value, right? In this case, NA. And if it is, then we execute next. Okay? So you haven't seen this before. This is actually an if statement all on one line. And we can do this, and we don't need to use the curly brace brackets when we do this. And you really don't see this very often. However, when you have a very short sequence like this where it's check if a condition holds, if it does, next, right? Then it's common to see it on one line. So basically here, we're going to iterate over each element of X. However, if it is a missing value, then we're going to use next to skip that iteration, don't do anything else, and jump into the next iteration in this for loop. Okay? So what happens is you see we print out the values of I. So this line of code is executed for 1, 2, and the third element in X. But since this condition holds for this third element here, we execute next, which skips that iteration. All right, the other option is a break statement. So a break means we're actually going to stop the for loop and we're not going to do any more iterations, right? So if we run this pretty much same code here, except instead of next, we use break. What happens is we go to iteration 1 and this condition does not hold for the first element. So we print out I, which is the value of 1. We go to the second element and that if statement does not, that condition does not hold for the second one. So again, we execute this code, which results in 2. Now the third element is NA. So this condition holds and we break out of the for loop. So we don't execute anymore. So we see now we never execute any code for that next element within X. Okay, so those are two main. So next is used if we're going to skip an iteration. Break is going to be used if we want to basically break out of the for loop for good. All right. So one thing to note is that break and next only control the progression of the direct loop environment they are in. Okay, what does that mean? Well, here we have a nested for loop, right? So we have a primary for loop that is iterating over X, and then we have an inner for loop that iterates over Y. And so what this shows, if you take some time to kind of follow the logic here, is this break statement here will execute this inner loop, but once this condition is met for this inner loop, we break out of the inner loop, right? So you can see we do 1, right? That's the outer loop for the first element of X. Then we go in and we do for J and Y, so we're executing now, iterating over this Y. So we see we do A, B, then the NA makes us break out, so that we jump into the second iteration of the outer loop. We do A, B, the break statement executes, we go out, and then we go to the third element in the outer loop and so on, right? So what this is doing is this is breaking out of the inner loop, but it's not breaking out of this outer loop. So the one thing to note is we can throw in an error, right? Recall that stop is a function that we can use to throw an error statement, right? And now when we have an outer loop and an inner loop, and if we use stop, then what that's going to do is stop the entire procedure, right? So that is a way that we can actually stop the entire process if we are operating within a nested loop, okay? So I know, like, when you look at these nested loops, it's a little bit overwhelming, or trying to follow along, it's difficult. Don't worry about that. That's not the point here. The key thing to remember is that break is only going to stop the current for loop that break is directly in. So if you have a nested for loop that contains a break statement, that does not mean it's going to break out of the external or overall for loop. All right, so what I'd like you to do is, again, we're looking at these month statements here. And this code, this example code here, so first of all, we pull out our data files of interest, which are our different month CSV files. And then this code right here, if you recall from the regular expression module, what we're doing is we're extracting the number that is within these file names. So we extract 01, right? We extract 1 there. We extract 02, so we get the integer 2, and so on. So it's extracting the number associated with those file names. So what I'd like you to do is we have this for loop here, which imports each of these files, changes the name, and then assigns the name to the data frame. So this is what we did in the last your turn. But what I want you to do is incorporate a next and or a break statement, right, to perform these two things. Number one, only import month 1 through month 7. So this can be thought of if we have a month that is outside of these boundaries, we want to skip that month. And then this one is only import month 8 through month 10. So one thing you can do about this is we skip all month values up to month 8, and then we can import month 8 through 10, and if the month value exceeds 10, we could break out, right? So monkey around, apply next and break statements to see different ways you could approach this. Okay, so number 1 here on the left, only import month 1 through month 7. So one way to approach this is we have our for loop, right? And our for loop is going to iterate over each of those file names. And then down here is where the code would execute. However, what we do is we throw in a break statement. So first we extract the month value, right, with this code that you saw before. Now, if that month value is greater than 7, here we break out, right? So what this would do is this would import month 1 through 7, and then once that value of month exceeds 7, we're going to break out and not execute any more code. Here's an option for number 2. Only import month 0 through 8, or excuse me, only import month 8 through 10. So in this case, what I do is I extract the month value, and then I say if month is less than 8 or month is greater than 10, we're going to skip those files. And so what that means is anything that is, less than value 8. So for the first several month files, we skip those. We don't iterate any of this code. Then once we get to month 8 through 10, we end up incorporating or importing these files. And then once the month value exceeds 10, we skip them again and we don't execute that code. Okay, so we've just been talking about for loops, but sometimes we need to execute or repeat code for an undetermined number of times. And basically what we're trying to do is execute code until some condition holds, and if that condition holds, then we can stop execution. So there's 2 very similar approaches that we can take with this. One is what we call a while loop. And a while loop is going to, while some condition is true, we're going to iterate and do some kind of code. Okay. The other option is we're going to use repeat. And repeat is going to execute code, and then we check if a condition holds. And we specify what to do if that condition holds. So these 2 are very similar. Okay. The main thing to realize is that a while loop will check the condition first and then execute code, whereas a repeat function will execute some code and then we can check if a condition holds and then break. All right. The main difference here is repeat, we have more flexibility in what we do if the condition holds or if a certain condition is met, where a while loop, basically all it does is if a condition ends up being false, we stop iteration. Okay, so what does this look like? Well, here's a simple example where what we're attempting here is to flip a coin 10 times and get all heads or tails in a row. Okay, so the probability of flipping 10 coins, let's say you could actually flip 10 coins all in parallel and getting all heads or all tails, the probability is actually this very small value, basically 1 in 1,024 tries. Okay, so if we wanted to basically imitate this within code, right, we could do this in 2 different ways. One, using a while statement. So here what we do is we create a coin. So this is just a vector that's got an option of heads or tails, right, equally weighted. So we set n tries to be 0, and then flip is equal to null. Okay, so we predefine these base values. So while the length of the unique flips, right, so what this is doing here is it's basically we're going to go ahead and flip coins later on, and we're going to see if the unique values in these are all heads or are all tails, right? So if the length of unique values in these flips, 10 flips, is not equal to 1, then we will continue to execute this code. Okay? So here the code is we flip, so we sample from our coin 10 times. This is basically just imitating a flip of 10 coins in parallel. And then what we do is we add number of tries. So this is just saying, hey, look, we started with try 0. We just did a flip, and we're gonna add 1 to our number of tries. And then what we do is we will check on the next iteration. Before we do the next iteration, this while loop will look at the flip that we just created. It'll take the unique values, right, heads or tails, and are all the unique values just 1, right? So with this here, if we actually run this code on our end, right? We get 1071 tries. Actually, that's pretty close to this 1 and 1024. Okay, so if I look at the last flip I had, we flipped all tails. So the unique values in flip is just tails, right? So now the length of the unique values in flip is equal to 1, right? So that's what this condition is just checking, right? If it is equal to 1, that means that we actually have only one unique value in here. It's going to be either all tails or all heads, and we stop that execution. The other option here is this code on the right. Here we create a coin. We're going to start with 0 tries, and we're going to iterate over each try. So now in this case, we use repeat. The first thing we do is we flip our 10 coins. We say, all right, we just did a flip, so I got to add number of tries. Now we do our conditional statement. If the length of our unique flips is equal to 1, I just print out how many number of tries we did first, and then we break out of that loop. And we see in this case it was 132. Now if I repeat this, we will likely not get the same results, and it takes 1,112. Again, that's a very similar number of times it takes our probability 1 in 1024, and we can look at our flip. And again, here we flipped all tails. Okay. We could re-execute that. 461 tries before we got all heads. Let's try. Can we actually get 332 all heads? Man, we really like to get heads. Flip. Tails. All right, there we go. All right, so here is a challenge for you. An elementary example of a random walk is the random walk on the integer number line, which here we'll just call it Z, which starts at 0, and at each step it moves plus or minus 1 with equal probability. So think of it, we start at the number 0, and we could either take a positive step or a negative step, right? We're going to add either positive 1 or negative 1 to that starting value of 0. And then on the next iteration, we're going to randomly add either a positive 1 or a negative 1 to that prior value. So see if you can actually perform a random walk here where you start at 0. Each step you either add or subtract a 1. So this should be a random process of either adding or subtracting 1, or in other words, you could add either a random number that's either a positive 1 or a negative 1. And then have your walk stop if it exceeds either 100 or if the number of steps taken exceeds 10,000. Okay, so what you want to actually fill in is this code chunk here, right? And this kind of walks you through the process, gets you set up. You're going to start with the value of 0, and you haven't taken any steps yet, so you have 0 steps. We're going to use a repeat looping construct. And what I want you to do is randomly add or subtract 1 to this value. Well, then what you need to do, since you took a step, you need to go ahead and add a value to our step. So we keep track of how many steps have we made. And then you want to check for a certain condition. And this condition is basically break if the value up here is greater than 100, or if the number of steps you have taken exceeds 10,000. All right, what does this look like? Well, here is the approach that I took, right? We have value and step both starting at 0. Now we're going to start looping and iterating. And so what we're going to do is take a random step of either 1 or a positive 1 or negative 1, right? So this sample here takes this vector of negative 1 and 1, and we sample one value, right? So we can see first time I'd sample 1, second time I'd sample 1, third time I'd sample negative 1, fourth time I'd sample negative 1, and so on, okay? So we're going to take a random value, either negative 1 or positive 1. Then we take our value and we add that random value that we just sampled. Now we're going to iterate and count the step. We just took a step, so we need to add 1 to step. And then we're going to check to see if the value is equal to 100. If it does, we're going to stop. Or if the steps taken exceeds 10,000. Okay. So we see in the run on these slides, the value reached 100 and the steps taken were 1,090. All right, so what does a random step actually, or a random walk actually look like? Well, it looks like this, right? So each step, each iteration that we do, we randomly add 1 or subtract 1, right? And you can see how some cases we build up multiple values and we take a big drop and we're actually doing a whole bunch of subtracting of 1s. And this is all just a random process, right? But it kind of looks like our stock market, doesn't it? And that's why they often call the stock market a random walk. Okay, so in summary, 3 main things we covered. For loops, which are looping constructs that we have a predefined number of times we want to iterate and execute some code. Lots of times that number of times is determined by the number of elements in an object. We talked about while and repeat loops, which is basically we want to repeat code a certain amount of times until a condition is met, or maybe a condition no longer holds true, right? And then we stop iterating. And then we also talked about the next and the break clauses, and that allows us to either skip an iteration in our loop or break out of our loop completely. All right, so you can rewrite, this is kind of cool, you can actually rewrite any for loop using a while loop, and you can also rewrite any while loop while using a repeat, right? But the converse is not true. So what that means is that the repeat is the most flexible. You can basically write any kind of looping construct that you wanted to with a repeat loop. A while is going to be the next most flexible looping construct, and for is the most rigid or least flexible. However, what common practice dictates is that you always want to use the least flexible or more strict solution to a problem, which means you should always start with a for loop if possible. If you can't complete the looping mechanism or logic with the for loop, the next option should be a while loop, and the last option should be a repeat loop. All right, so generally speaking, you can minimize the use of for loops in R since it is vectorized in a functional programming language. And there's actually a bunch of functional programming implementations of these looping constructs, and this is often using the purr package, P-U-R-R-R, and there's a bunch of what we call map functions that basically are performing these for loop iterations, but within a vectorized approach. I did not cover that. We're not covering that in any slides, but it's in the reading lesson for this week. And I highly recommend you take some time to take a look at that and familiarize yourself with the difference in how that looks and behaves from a normal for loop approach. All right. So with that being said, definitely dig into the lesson reading for this particular lesson. Gives you a lot more code examples, gets you doing some more hands-on examples. And if you have additional questions, please go ahead and hit up the discussion board on Canvas.